talking about section 11.2, finding the area and perimeter, I suppose, of trapezoids, rhombuses, and kites. Starting with trapezoid, which is a formula you all should be familiar with. It's the area of a trapezoid equals 1/2 times the height times the sum of the bases, as given by this guy here. And it should look familiar. You probably used it before in a middle school math class, probably not at the high school level yet, since you don't really cover too much of this in Algebra 1. But I want to talk about where this formula came from, because it's not just some voodoo math. This is the theorem, which means it has been proven. There's a proof of it somewhere. So let's look at it. But why, Fred? Why is this the formula? Well, let's look at trapezoid FRED, or Fred, and discuss it. So there's two ways we can look at it. One way is, let's say I have Fred here, and let's say that I duplicate him. So now Fred has a clone. So let's say I take the clone of Fred and flip him upside down. And I'm going to put him right next to original Fred. So that means that B1 is now at the bottom down here. B2 is now at the top up here. Well, you might notice that these two trapezoids together forms what appears to be a parallelogram. And to find the area of a parallelogram, we know that that is going to be base times height. Well, my base is really B2 plus B1. My height is still the same, h. I'm going to put it in the front here. And so that's the area of this whole parallelogram. However, my trapezoid is only half of the entire parallelogram. So I put that half in front. And that's where we get the formula 1/2 times the height times base 2 plus base 1, or vice versa. So again, the whole parallelogram here is the height times B1 plus B2. But since a trapezoid is only half of this whole thing, we put the half in front. That's one way to look at how this was derived. Let's look at a second way using triangles. So let's say, again, we have trapezoid Fred. And this time, instead of cloning Fred, I'm going to cut Fred in half. So I have two triangles. Triangle number 1, which I'll highlight in green here, and triangle number 2, which I'll highlight, let's do that in blue. So to find the area of the green triangle, it's 1/2 times the base times the height. So for the first one, it's 1/2 times the base, which is labeled as B2, times the height, which is labeled as h. When looking at my second triangle, again, it's 1/2 times the base times the height, but I don't have a height in this triangle. There's no perpendicular segment, so I'm going to draw a height out here. Now this height is the same as my original height. It's just kind of moved over to the outside, so I'm still going to call it h. And the base of this blue triangle, the part that's perpendicular to the height, is B1. So that's the base of my blue triangle. So if I add these two together, so my green one, which is 1/2 B2 times h, and 1/2 times B1 times h, if I add these two triangles together, it equals the trapezoid as a whole. So what we can do is employ some Algebra 1 skills and factor some things out. We have 1/2 that's in common, I'll factor out. We have h that's in common that I'll factor out. And the only thing that's left inside is B2 plus and B1. And that's how we get the formula for the area of a trapezoid. So we have two different methods we can employ. Either way, this exercise is just so you have a glimpse as to why the area formula of a trapezoid is what it is. You won't be asked to necessarily recreate this, but it's something that if you're really mathematically driven, you will be interested to see how it works. Or at least I think it helps students when you understand where something came from instead of just going with the flow. The second two shapes we're going to look at are rhombuses and kites, and the areas of both of these are found the same way. So back from the unit on quadrilaterals, we know that these both have a pair of diagonals. And in kites and in rhombuses, we know that the diagonals are perpendicular to each other. In order to find the area, you take 1/2 times one diameter times the other diameter. Same thing in a kite. 1/2 times one diameter times the other. And your diameters can be labeled inside like the red lines are outside like the black lines. So you'll see them labeled in a couple different ways. So for both of these shapes, the area equals 1/2 times diagonal 1 times diagonal 2. So D is representing diagonal. So let's look at a few basic examples of how to find the area of rhombuses, kites, trapezoids. Let's look at one of each. So for number 1, we're finding the area of the figure. Well, you should notice it's a trapezoid. We have one pair of parallel sides, since consecutive interiors are supplementary. And that is with the definition of a trapezoid. So the area of this trapezoid is going to be 1/2 times our height, which is 4, the perpendicular portion of both bases. And your bases, your parallel sides, are 8 and 6. Using some quick mental math, 1/2 of 4 is 2, and 8 plus 6 is 14. So the area is 2 times 14, or 28, and that's in units squared. For number 2, we have a kite. We know it's a kite because we have 2 pairs of congruent sides that are not across from each other. They're next to each other, so they're consecutive. So that means we're going to employ the formula 1/2 times diagonal 1 times diagonal 2. Well, our shorter diagonal is 6, and our longer diagonal is 14. It's just labeled on the outside. We could label it on the inside as 14, but then there would be a whole lot of space. It'd be kind of crowded in there, so it's labeled on the outside. 1/2 times 6 times 14, well, I could take 1/2 of 6, which is 3, and 3 times 14. Or I could say 1/2 of 14 is 7, and 7 times 6. Either way, it's 42 square units. And lastly, for number 3, this is a rhombus because we have 4 congruent sides. It could be a square, we're not sure. It's just some type of rhombus. So we're going to also use the 1/2 times D1 times D2. Well, one diagonal, 1/2 of it is 30. The other 1/2 of it should also be 30. So the whole thing is 60. We know that because a rhombus is a type of parallelogram. And parallelograms, the diagonals bisect each other. So both of these halves should be the same, so they're both 30. Same thing here. Both halves are 40, so the whole thing is going to be 80. So our 2 diagonals are 60 and 80. And 1/2 of 60 is 30, so it's really 30 times 80. And 3 times 8 is 24. And we have 2 zeros to add on, so it's 2,400 units squared. So those are a few basic examples of how to find the area of each figure. Let's look at a couple more complex ones. The diagonal of a kite is twice as long as the other. The area is 72.25 square inches. What are the lengths of the diagonals? Well, first of all, it's a kite. So we're going to use our area formula for a kite since we are given the area. So the area is 72.25. We don't know diagonal 1 or diagonal 2. What we do know is that one diagonal is 2 times the other one. So I'll say diagonal 1 is 2 times whatever diagonal 2 is. So instead of using diagonal 1, I'm going to plug in 2 diagonal 2. And the reason for that is that if I have 2 variables in one equation, there's not enough information to solve it. I want to somehow turn this into 2 variables into the same one so I can solve for it. So simplifying, well, the 1/2 and the 2 cancel, so I have d2 times d2. Well, d2 times d2 is just another way of saying d2 to the 2nd power. And it looks kind of funny because you have 2 2's here, but it's d sub 2 to the 2nd power. So to get rid of a square, we take a square root. So we need to find the square root of 72.25. Which I'm going to guess is something 0.5. So let me see in my calculator here. So square root of 72.25 is 8.5. So there's one diagonal. We know D1 is 2 times whatever that was. So it's 2 times 8.5. So D1 is 17. And we're finished. And I should note that these are in inches. Always remember your units. Let's try 2 more problems. You have a map of a city park. Each grid square represents 10 meter by 10 meters square. Find the area of the park. So that means each square is 10 meters by 10 meters. So this appears to be a trapezoid. We need to find our 2 bases and our height. So our first base, if these are all 10 meters, then this is 10, 20, 30, 40, 50, 60, 70. 70 meters. This is 10, 20, 30, 40 meters. And our height is 10, 20, 30, 40, 50 meters. To find the area of the whole park, we'll say, well, the area of this trapezoid should be 1/2 times the height times the sum of the bases. So our height is 50, and our bases are 70 and 40. So some mental math here. Half of 50 is 25. 70 plus 40 is 110. So 25 times 110, that's going to be the total area in square meters of the park. So 110 times 25 is 2,750 square meters. So usually if you see something in the coordinate plane, don't panic, because usually you won't have to use your distance formula or the Pythagorean theorem. Even if you did, it wouldn't be that hard of a problem to solve. And let's do one last challenging one. This one right here, number 1. So I'm going to clear some space over here at number 2 and just make it invisible. All right, so we're finding the area of the shaded region. I don't know if you can see it on your screen at home, but these triangles here, that's the shaded region. So in order to do that, let's find the area of the entire thing and then subtract the area of this missing piece in the center. Well, the entire thing appears to be a trapezoid. So to find the area of this whole thing, the trapezoid, that's 1/2 times the height, which is 10, times the bases added together, so 11 plus 15. And if we go through the process, this ends up being 130 square units. The whole thing is 130. But we need to take out this missing piece here in the center and subtract that from 130. Because 130 includes this, but we want to take it out. So that is a rhombus. We know it's a rhombus because all 4 sides are congruent. So to find the area of a rhombus, it's 1/2 diagonal 1 times diagonal 2. Well, one diagonal is 10. It's just brought over from the inside. So that's 10. We need to find our other diagonal here, which we don't know at the moment. So we know one of them is 10. We don't know the other one. Well, let's look at the big picture here. This is a trapezoid, and these are midpoints. That means this is the midsegment of a trapezoid. So to find the length of a midsegment, I'm just going to call it AB. You take the average of the bases, so 15 plus 11, and divide by 2. We did that back in Chapter 8. So this midsegment ends up being 13. Again, we know it's a midsegment because A, it's in a trapezoid, and B, it connects 2 midpoints, so we can take the average of the bases and get 13. So the area of this rhombus ends up equaling 65, right? Yeah, 65 square units. And I should probably turn that to be red if possible. Nope. So we know that the area of the whole thing is 130. Area of the missing piece is 65. So 130 minus 65, and our final answer happens to be 65 square units. So problems like this that are similar to the problems, the challenging ones from Section 1, will also be in Section 2. Hope the video is helpful. Any questions, please email me or see me before or after school.